Hello everyone, in this video I'll be explaining you the problem minimum k to reduce array within limit. So this problem was asked in Leetcode Biweekly contest 175. So let's read out the problem. You are given a positive integer array nums. For a positive integer k, define non-positive of nums comma k as the minimum number of operations needed to make every element of nums non-positive. In one operation, you can choose an index I and reduce nums of I to k. Sorry, not reduce to k, nums of I by k. We can reduce to nums of I minus nums of I equals to nums of I minus k. So return an integer denoting minimum value of k such that non-positive nums of nums comma k is lesser than equals to k square. So this problem looks a little weird, but it's very easy. I'll tell you. So we have 3, 7 and 5. Okay, so let's go to the board and see what this problem statement is. So we have nums array as 3, 7 and 5. So in the problem statement what they've said is they've given as nums array, okay, and its size is n, length of nums. So what we can do is they've said is it non-positive? Yes. So they've said non-positive of nums comma k is basically if you see this, it's basically minimum number of operation. Okay, minimum number of operation to make all array elements to be non-positive. Okay, so meaning of non-positive is a number which is not positive. So a number which is not positive is in the range nums of I is less than or equals to 0. So 0 is also a non-positive number. Okay, 0 since it is neutral. So this is our range. I think these things have got it. So in the question what they have said is we have to find this k which is minimum. Find k and we have to find the minimum k in such a way that the operation what we are doing is non-positive, right? Non-positive of nums comma k. So whatever this is the number of operations you're doing, right? Let me call this operations. So this operations should be lesser than equals to k star k. So we have to choose this k. I think the problem statement is kind of looks weird. So let me try to explain you how we can do this, and while explaining you will get to know the optimal approach as well. So what I'll do is I will try to choose k is equal to the smallest one, because they have asked you to choose k, minimum k. So I'll choose the smallest one. When I choose smallest one, so now you have to make all the array elements to be non-positive. When you're making that to be non-positive, so in one operation you can choose any index and make that array element reduced by k. Okay, your k is 1, So this element is going to be reduced by 1, which is 2. Okay, so it's like you have done one operation. So in the since it is again it is positive only, you have to make non-positive. Again you do this same operation. So it's like you have done two operations now. Okay, now again it is positive, reduce it. So it is now it is non-positive. So we will leave this. How many operations you have done? We have done 3 operations. Got it. Now do same with 7 as well. So it was 3. So when k was 1, so you have made 3 operations. In the same way, it is 7, and your k is 1. So you will be doing again with 7. You will be doing 7 operations in total. Same way with 5. So 5 operations you will be doing. So in total, how many operations you have done? 15 operations you have done, right? So operations are 15. So your this function is going to look like non-positive of this nums array comma 1, because k we have chosen it as 1. This is going to be 15, and they have said this has to be, let me call this as operations, has to be less than equals to k star k. So 15 less than equals to k is 1, 1 star 1 is true, it is not. So your k is not valid. Okay, we have got it. Now what we can do is k1 is not a valid one. Now we will take again 3, 7, 5, and this time we are trying to choose k is equal to 2. And why I have not chosen k is equal to 0 in the previous case? The reason being is 3 minus k, or any element minus k, if you are doing with 0, so the element remains as it is. So you can't do it, you can't reduce it, right? That's why. Now when k is 2, you'll choose again the first one. So 3 minus k is going to be 1. One operation you have done. Now again it is positive. 1 minus k, when you do, it is minus 1. it has gone to minus 1. So you have done 2 operations here. Now choose with 7. 7 minus k, it is going to be 5. 5 minus k, it is going to be 3, because k is 2. Now 3 minus k, it is going to be 1, and 1 minus k, it is going to be minus 1. So you have done here 4 operations. So this again we can simplify. I'll tell you how to simplify. What you can do is you divide 5 by 2. When you divide 5 by 2, it is going to be 2. But when you do modulo with 2, so it's like when you divide 5 by 2, like 2 times you will be doing these type of operations. And when you have modulo also, it means after division there is some remainder. So that also we need to, because the remainder means it is like positive. So again you have to do minus. So again one more operation should be doing. So basically in this case 3 operations will be doing. If you try to check with this one, so 7 by 2 is 3. But how many operations you have done? 1, 2, 3, 4. So 7 modulo 2 is like 1, right? Because it has some remainder. So when you again, whenever there is a remainder, so we just take one more addition operation. So the total operation is 4. So you don't need to do these things. So in the code I'll be doing this thing only. Okay. The meaning of this is like when you do 7 by 2, it is 3. It's like 7 can be written as your division plus 1, right? You can write this 2 into 3 plus 1. So it's like 3 times you have done reducing operation. In general it will be k. Okay, and this will be remainder. Okay, so yeah. So in the if you see now how many operations we have done, 6 plus 1 is 9. So in total 9 operations I have done. Is it equals to k star k? 2 star 2 is 4. No. Again k is not valid. I will try to make k is equal to 3 now. So when your k is 3, how many operations operations required to make this element as non-positive? We do it by 3 divided by 2, and you do 3 modulo 3. 3 modulo 3 is 0. Whenever it is 0, so in total it will be just one operation. So in one operation you can do, you can check also 3 minus k is going to be, since k is 3, so it is going to be 0. Now let's do this 7. 7 by 3 is going to be 2, and 7 modulo 3 is going to be 1. So how many operations? We are doing 3 operations here. Okay. Now 5. So 5 modulo 3, sorry, 5 divided by 3 is going to be 1, and 5 modulo 3 is going to be, since it has got a modulo, so it's like one operation we will be doing. Okay, so again you will be doing 2 operations. 5 modulo 3 is going to be 2 answer, but I'm here just calculating how many operations will be doing, right? Even if modulo is 2, so it's like you are having 2 at the end. So 2 minus 3 when you do, minus 1. So one operation is good enough. That's why minus 1. Sorry, 1. So now how many operations? 6. Let's check it. 6 you have, less than equals to k star. K square, they have asked in the question, so I was writing k into k. 6 less than equals to k star is 3 into 3 is 9. It is true. So this is the smallest k wherein this condition holds good. Okay. So I think you guys have understood how to solve this. Basically you will be choosing k, which is from 1, and you make sure to do these operations and find how many operations we have done. And when you have done these operations, now you take number of operations into whatever chosen k you have, k star k. If this condition is holding good, so since you are starting k from the lowest to highest, so the first element, lowest to highest, right? So the first element that you will get will be the lowest k possible. But if you do this operation, since your nums of I is 10 power 5 and length of the num and is also 10 power 5, so it is going to be of n square solution, because you are choosing k from 1 to till nums of I, right? So it will be n square solution. So this is not going to be a valid one. So now after this simulation, you should be good enough to understand like what is the main concept behind this problem to solve, because we were doing it linearly, right? Whenever there is an option from choosing lowest to highest or highest to lowest in a sequence, so in that case you need to choose the binary search. So binary search will make sure you have chosen this k in log time, right? Log time. So that's why we'll be doing by binary search. So your nums array is 375, right? So it's a 375. You choose your left to be 1 and right to be 10 power 5, because in the question they have given at max the element will be 10 power 5. Now same thing you will be doing in the while loop. While your left is less than right, you calculate mid. Your mid is going to be L plus R by 2, right? Once you find the mid, it's like it's a k for you. Now you find the operations. We'll write one function, find operations, right, wherein we'll pass this mid and we'll pass this nums. So this function will give us how many operations are required in order to make all these areas non-positive using k is equal to mid. Now we'll be checking if operations is less than equals to this mid star mid. Instead of mid you can call this k as well. Just I'm going with the flow like how we do in binary search. So if this is the condition, which means it is a valid one, so you take one answer variable as well. Initialize nothing. Your answer is going to be this mid. It's like you have got the answer, but you need to find still the smallest one, right? The smallest one, in order to find, you have to you have your left and right range, and this was the mid, right? And you have found this answer is valid. So now you don't go here in this range, because in this range again k value whatever you will be choosing, that will be valid with the answer, but since this k will be minimum, so you try to reduce the k still, so you move in this direction. So your r is going to be mid minus 1, else if it is it's like you have not found the answer, so this is not the range, you'll have to move your left pointer. So it is going to be mid plus 1, r was mid minus 1, right? So yeah, once you come out of the loop, you need to just return the answer. And find operations I'll be showing in the code. Let's try to code it up. So I'll not be doing using linear search, I'll be using binary search. I'm taking 1e5 as the maximum element, because in the answer they said max element could be like 10.5. So now I'll take one answer variable. Now I'll run a loop from left equals to right. A typical binary search I'm doing. I'll take one int k. We can take mid also, or we can take k. So k makes more sense because in the question they have said k. So your k is basically the k is mid, okay? And this I think you guys know, like it will not overflow, right? Whenever left and right both are like and int max values or something like that, let's take int max value only. So when you have int max value, in that case you can't do l plus r, because l plus r is going to be 2 times int max, right? So it will not hold in integer. So that's why when you do r minus l, so r minus l will give you 0, and by 2 again will give you 0, and plus l which is int max, it is going to be int max. So in integer range it is going to hold. So it just take case of overflow, that's it, nothing else. Now let's call operations. Let's find the operations, and k will be passing and it will be passing nums. Now we need to check if this operation is less than equals to k star k. Then you have answer as k, and you need to find the minimum still. So minimum is going to be a mid minus 1. So like minimum k still you want to find, but if this condition is not holding, which means the k whatever you've chosen, it is very small, so you need to move your left pointer to mid plus 1. So when you're coming out of the loop, you need to just return the answer. Now let's try to find the number of operations. So we'll be finding number of operations. Operation initially it is 0. So as I said, how can we find operations? We'll take a loop, for each loop, okay, 1 by 1 element will take. So your operation is going to be num by k, okay, and we need to find if this num modulo k, if there is any remainder, which means still the number is positive, so we need to make one more operation, like basically that number minus k if you do, so the number is going to be a non-positive then. Else yeah, at the end you'll have to return the number of operations. Let's try to run it. Okay, it shouldn't be mid, it should be k, my bad. Okay, I got what it is, like if you take 10 power 5 into 10 power 5, so it is going to be 10 power 10, so integer is not holding, So we can do one long. Basically type convert this to long. Divisible by 0. Sorry, this shouldn't be 0. Like left always should start with 1. As I said, showed on the board, like when you do when you subtract 0, so number will not change, right? That's why. Yeah, it is getting passed. Let's try to submit it. Yeah, it got accepted. And if you try to analyze the time complexity of this, so we have taken a binary search. So this while loop is going to take log n and this find operation is going to take O of n. So in total the time complexity is n log n, and the space we are not using any extra space, so it is constant. So yeah, thank you guys for watching the video.